Okay, a student investigates the enthalpy of solution delta H solution for two alkali metal halides, lithium chloride and sodium chloride. In addition to the salts, the student has access to a calorimeter, a balance with a precision of plus or minus 0.1 grams, and a thermometer with a precision of plus or minus 0.1 degrees Celsius. So a couple things, when I see the words enthalpy of solution delta H and especially calorimeter, I think of one equation, which is Q is equal to MC delta T. So I'm guessing we're going to have to use that at some point. And then also when they're giving me two different compounds, I'm going to think that I might have to compare these two at some point. So part A says, to measure delta H for lithium chloride, the student adds 100 grams of water initially at 15 degrees Celsius to a calorimeter and adds 10 grams of lithium chloride solid, stirring to dissolve. After the lithium chloride dissolves completely, the maximum temperature reached by the solution is 35.6 degrees Celsius. Okay, so again, probably you'll have to use Q equals MC delta T as they're giving us two different temperatures, the final and the initial. Part 1 says, calculate the magnitude of the heat absorbed by the solution during the dissolution process, assuming that the specific heat capacity of the solution is 4.18 joules per grams degree Celsius. Include units with your answer. Part 2, determine the value of delta H solution for lithium chloride in kilojoules per mole reaction. If you haven't noticed, the units switch. So part 1 actually uses joules and part 2 uses kilojoules. So just be careful when you do calculations. I'm going to read the next part. It's actually not relevant until after part A, but let's just read it. So it says, to explain why delta H solution for sodium chloride is different than that for lithium chloride, the student investigates factors that affect delta H solution and finds that the ionic radius and lattice enthalpy, which can be defined as the delta H associated with the separation of a solid crystal into gaseous ions, contribute to the process. The student consults references and collects the data shown in the table below. So if you look at the table, the only thing to really notice is that the lithium ion is smaller than the sodium ion. Okay, so let's go back to solving problem number 1. So the first part of question A is asking you to find the heat absorbed, which is just Q, which is equal to MC delta T. They gave you some data. So they first gave you the mass of the water, which is 100 grams. They also gave you the mass of lithium chloride solid, which is equal to 10.0 grams. And then they gave you the final temperature of 35.6 degrees Celsius and an initial temperature of 15 degrees Celsius and a specific heat of 4.18 joules per grams degrees Celsius. So all you have to do here is just plug in the numbers that are given. So Q is equal to 110 grams. A lot of students put 100 grams instead, meaning they just put in the mass for the water. Remember, this is a solution of lithium chloride being dissolved into the water. And then for C, you would have 4.18 joules per grams degrees Celsius. Your delta T is going to be 35.6 minus 15 degrees Celsius. So another common mistake was swapping the temperatures around. Just remember that a delta usually in science or math means a final value minus an initial value. So you should have gotten for Q 9470 joules, or you could convert this into kilojoules as 9.47 kilojoules. I should note that each part in section A is worth 2 points each, so basically 4 points total for part A. And then for part 1, the breakdown was basically 1 point for using the correct equation, and then another point for calculating the correct value with the correct units. Okay, so let's do part 2. So part 2, it says, determine the value of delta H solution for lithium chloride in units of kilojoules per mole reaction. If you're thinking about using the value from part 1, you're correct. So basically your delta H solution should be something like 9.47 kilojoules. A common mistake was just putting moles reaction on the bottom. This is wrong. So remember that they actually gave you a value of a solute. So they gave you 10 grams of lithium chloride. So you need to find the moles of lithium chloride that you actually dissolved. I'm going to assume that everybody knows how to do mole conversion. So basically you have 10.0 grams of lithium chloride solid, and you just have to multiply it by its molar mass. So basically 1 mole of lithium chloride over 42.39 grams of lithium chloride. And this equals 0.236 moles of lithium chloride. So then delta H solution should equal 9.47 kilojoules over 0.236 moles, and you would end up getting 40.1 kilojoules per mole reaction. So the point breakdown here was basically 1 point for doing the mole conversion, and then 1 point for the correct units and value for the delta H. So if you left it at positive 40.1 kilojoules, that's actually wrong. You actually need to put a negative because it's actually an exothermic reaction, which I'll talk about in the next section. This problem is testing on delta H solution, which has two parts to it. The first part is called lattice enthalpy or lattice dissociation enthalpy. I'm just going to call it delta H lattice for short. So in order for lithium chloride to actually dissolve in water, you have to break the ionic bond between lithium and chloride. Breaking bonds involves absorbing energy, meaning this process is endothermic. And then anything that's endothermic will have a delta H that's positive. Technically, what's happening here is you're taking lithium chloride solid and it's being converted into ions, lithium and chloride ions. And these are actually in gaseous state. The second process is called delta H hydration, and it is exactly what it sounds like. So basically you have these lithium ions and chloride ions, and then you also have water, and water is a polar compound, meaning it has a positive dipole on hydrogen and a negative dipole on oxygen. Since lithium is a positive ion, it's going to be attracted to the oxygen side. And then since chloride is a negative ion, it's going to be attracted to hydrogens, which again have a positive dipole. So basically all these ions are being surrounded by water molecules. This process is exothermic, meaning it's releasing heat, so your delta H should be negative. Recall that the calorimeter got warm because the solution was releasing heat. So delta H hydration is actually larger than delta H lattice, which means that your overall sign for delta H solution is negative, which is why for part 2 of that answer, you had to put a negative or else you wouldn't get full credit for it. Some other minor details: when you're making a solution, you're taking gaseous ions and converting them into aqueous ions. And also, you have these hydrogen bonds that are happening between the water molecules, and they actually have to break when you're dissolving. Okay, let's go to part 2.